In this video, we're going to discuss asymptotes and holes, which will include vertical asymptotes, holes, horizontal asymptotes, and slant asymptotes. Vertical asymptotes happen at zeros of the denominator that are not zeros of the numerator. So you'll factor the denominator and the numerator. If the zero is only a factor of the denominator, it will be a vertical asymptote. Otherwise, it'll be a hole. We'll talk about that in a second. So when they do cancel out of the numerator and denominator, we get a hole. So running through this example real quick, I'm going to factor the denominator. These two would cancel out, so we have a hole at x equals -5, and we have a vertical asymptote at the line x equals -3. You try the second one. For horizontal asymptotes, there's a few rules you need to remember. If the degree of the denominator is higher than the numerator, you get an asymptote at y equals 0. If they're equal, you make a fraction with the leading coefficients. And if the numerator has the greater degree, you get no horizontal asymptotes. Here's what that looks like. So in the first example, the degree is greater in the denominator, so we get y equals 0. In the second one, they're equal, so we do 3 divided by 1, which gives us 3. And in the last one, the degree is greater in the numerator, so there is no horizontal asymptote. So this will be a short question for you to answer. And then the last one for us to cover are the slant asymptotes, which we'll use either our long division or synthetic division to find. N has to be exactly 1 greater than m, and we will divide the numerator and the denominator and use the non-remainder part of the quotient to get our slant asymptote. So for example, we're going to take, and I can use synthetic division here, so I will. -2 will go in the box. 1, 1, -6. 1 times -2 is -2. Add those together, get -1, which gives us +2, which leaves -4, and this part's the remainder. So we get, for the slant asymptote, it will be y equals x minus 1. Because we had an x squared, so we drop down to the next degree, and then this becomes the equation of the slant asymptote. And last quiz question for you, find the equation of this slant asymptote.